Okay, so these are your notes for today. The video will stop periodically and ask you to answer some questions. This is how I know that you actually watched the video and give you credit for it. It doesn't necessarily matter if your answers are right, but I do expect an attempt. So, up until now, we've been talking about doing calculations on how much of this do we need to make this, or if I use this amount of that, how much will I make? Today we're going to talk about how to deal with reality because things do not always go exactly how we expect them to go. So we're going to start by talking about something non-chemistry related so that we can get some terminology down before we move on to actual chemistry. So if we have a fake reaction where I am trying to make a sandwich, and in order to make one sandwich, I would need 2 pieces of bread, 3 pieces of ham, and 1 piece of cheese. How many complete sandwiches can be made from 8 pieces of cheese, 10 pieces of bread, and 12 pieces of ham? Looking at what I started with, I know if I start with 8 pieces of cheese and I need 1 piece of cheese to make one sandwich, I can make 8 sandwiches total. If I have 10 pieces of bread, and I know it takes 2 pieces of bread to make one sandwich, I can make 5 sandwiches total. If I have 12 pieces of ham, and I know I need 3 pieces of ham to make one sandwich, I can make 4 sandwiches total. So now for some vocabulary. Thinking about our sandwich example, we have something called limiting and excess reactants. A limiting reactant is the reactant whose amount limits the amount of product that can be made. So thinking back to our sandwich example and our ham, bread, and cheese, which of those 3 starting reactants limited the amount of complete sandwiches I can make? Ham is the ingredient that made the least amount of sandwiches, so that's going to be our limiting reactant. I will run out of ham first. The other reactants are known as our excess reactants. Excess meaning left over or too much. So the reactant that would have extra left after the limiting reactant has run out are known as our excess reactants. So our excess reactants in our sandwich example would be our bread, and that would have some left over. And then our cheese would be our other excess reactant, because I will still have some of those left over after I run out of ham. Some other vocabulary is our theoretical yield. Our theoretical yield is the maximum amount of product that we can make using math. So if we look back at our sandwich example, the maximum amount of complete sandwiches I could make was 4. This is always found by looking at our limiting reactant and see how much of our product we could make by using that limiting reactant. So in our sandwich example, it would be 4 sandwiches because I would run out of ham after that. Our actual yield is the amount of product that was actually recovered in the reaction. This is found using lab data, or on your worksheet, it'll be the amount that is actually recovered. If my dog jumped on my counter and ate one of the sandwiches, what would the actual yield be? 3 sandwiches, because the dog ate one, which means I have 3 sandwiches left to work with. Once we have both of those numbers, we can calculate what's called a percent yield. Our percent yield is the percentage that we actually made. The higher the percent yield is, the better you did in that lab, the more successful you were. Percent yield is always actual yield over theoretical yield times 100, or as how I like to remember it alphabetically, A over T. Calculate our percent yield for the sandwich example. I can plug in my actual yield, which would be 3 sandwiches. I am actually able to eat 3 sandwiches because my dog ate 1. My theoretical yield is how much in theory I should have been able to make, which would have been 4 sandwiches. Lastly, I multiply it by 100 to make it into a percent. So my percent yield of sandwiches was 75%. All right, now let's throw some chemistry in here. So on your screen right now is a balanced equation. Take a moment and turn that word equation into a formula equation. This is the correct balanced equation. 2 sodiums plus 2 hydrogen chlorides will make 2 sodium chlorides and 1 H2. Remember, H2 is an OFI in broccoli, while sodium is not. Now that we have a balanced equation, because just like everything else in this unit, this also starts with a balanced equation in order to do any math with it. But now that we have that, I can use that to start calculating what my limiting reactant is going to be. So for example, this question says, what is the limiting reactant in the production of sodium chloride if 22.5 grams of sodium reacts with 30 grams of hydrogen chloride? In these problems, you're always going to be given amounts for your reactants, which in this case is my sodium and my hydrogen chloride. Those are my reactants. And you'll also be given a target product. In this case, my target product is sodium chloride. When we do these types of problems, you're just going to do some stoichiometry just like we've done the last couple days in class. So I'm going to set up 2 different stoich calculations, one starting with sodium and one starting with hydrogen chloride, and both ending in our target product of sodium chloride. So I can start with my sodium. The problem tells me that I'm starting with 22.5 grams of sodium. Now I need to figure out how much sodium chloride I can make in the end. But before I can switch to sodium chloride, I need to get into moles in order to use my balanced equation. So I'm going to go to my periodic table, and I know that there are 22.99 grams of sodium in every 1 mole of sodium. Once I'm in moles, now I can use my balanced equation. Looking on the previous screen, I know that for every 2 moles of sodium, I can make 2 moles of sodium chloride. Now moles are useful, but grams are more useful, so I'm going to keep going, and I'm going to use my periodic table again to convert into grams. So again, I know it's always 1 mole when it's grams. I went to my periodic table and I added up 1 sodium and 1 chlorine, and I got 58.44 grams. So now I can solve. When I put that in my calculator with sig figs, I get 57.2 grams of NaCl. We're going to do the same calculation again. This time we're going to start in HCl. So my problem says I have 30.0 grams of HCl starting with. Finish off that stoichiometry problem so you end in grams of NaCl, just like we did up above. Check to see if your work matches mine. I have 30 grams of HCl. I divided by the number off the periodic table to get to moles. Then I used my balanced equation. It's a 2-to-2 ratio. And then again I multiplied by the number off the periodic table to get into grams of my target product. I found that with my starting amount of HCl, I can make 48.1 grams of NaCl. Now is the time to decide what my limiting reactant is. Just like in our sandwich example where the ham made the least amount of sandwiches, I also want to look here to see which reactant made the least amount of my target product. In this case, because 48 is less than 57, HCl made less of my target product. So HCl is going to be my limiting reactant. Because HCl is my limiting reactant, that also makes that 48.1 grams that I can produce from my limiting reactant my theoretical yield. That is, in theory, the maximum amount I can make of my target product, because after that, I run out of my HCl. Because my HCl is my limiting reactant, that makes sodium my excess reactant. We can now answer some questions that go with that last slide. So it says, what is the theoretical yield of sodium chloride in moles? Well, on our last slide, we saw that my theoretical yield, which is what we're looking for here, was 48.1 grams of sodium chloride. Now the question's asking for moles, so I'm going to need to backtrack a little bit here. I'm going to start with my 48.1 grams from the last slide, and I'm going to put it back into moles by dividing by that number off the periodic table. That would be that 58.44 that we already calculated. Grams of nickel, 1 mole on top. I put that back in my calculator, and with stick figs, I get 0.823 moles of nickel. That's how much, in theory, I should be able to make in moles. Now, part D asks for the theoretical yield of sodium chloride in grams. We like this because we already calculated it. I can just write it down, 48.1 grams of NaCl. Again, I got that by looking at my limiting reactant on the last slide. Part E says if 22.1 grams of sodium chloride are recovered in the reaction, what is the percent yield? Remember, the equation for percent yield is equal to actual over theoretical times 100. Again, alphabetically, A over T. Actual is the amount I actually made. Theoretical is the amount in theory, using math, I should have been able to make. So I can plug in my numbers. The question told me that I actually recovered 22.1 grams. So that's going to go on top because that's how much I actually made. The 48.1 from the question above is going to go on the bottom because that's how much in theory I should have been able to make. Multiply by 100. I found that I should make I made 45.9% of what I should. Not very good, unfortunately. Here's another example. Why don't you try this one all the way through and then check your answers in the end? I will pause this so that you can check your balanced equation before you move on. Here's your correct balanced equation. Make sure you actually use this one when you're doing the rest of your calculations. All right, so this is asking that same question that was asking before. It says, what is the limiting reactant when 5 grams of aluminum is heated with 10 grams of sulfur? Again, these are my reactants, aluminum and sulfur. This one doesn't outright say what our target product is, but that's okay because we only have one product in our balanced equation, and that's that aluminum sulfide, Al2S3. Go ahead and try this one all the way through. When you're done, enter your answers in to the form, and then the answer key will pop up for you. Check to see if your answers match mine. I found that aluminum would make 14 grams of aluminum sulfide, and sulfur would make 16 grams of aluminum sulfide. Because aluminum made less of my target product, it's my limiting reactant. That makes sulfur my excess reactant. Pause the video if you need to copy this down. Here are similar questions to the ones we answered last time with this. Take a moment and solve these three, enter your answers in, and then check your work. Check your work. For C, I know that my theoretical yield in grams is 14, so I needed to backtrack one step to get back to moles. I divided by my number off the periodic table to get 0.093 moles. From there, D is really easy because I already have grams because I found it before, 14 grams. Now, E is a slightly different version of that question from before. This time I gave you the percent yield and asked how much you would have to recover in order to reach it. Again, percent yield is equal to actual over theoretical times 100. If I'm trying to get an 83% yield, I'm going to set that equal to my actual, which is what I'm solving for, over my 14, which is my theoretical, times 100. When I solve with sig figs, I get 12 grams. I would need to recover 12 grams in order to reach that yield. Now that we've gone through the notes, your homework is worksheet 2. We will go through it on Monday, and then we'll do some extra practice just to make sure everybody knows what's going on. Feel free to send me an email if you have a question, or come in for a resource on Monday morning too. See you on Monday.